I will now start going through the JAM paper. Now, the JAM paper I am working on is this 021 draft, which you will not have a printout of, almost certainly, because I only released it an hour or so ago. You can find it on the GitHub, Grey Paper GitHub. I don't know if Philip has woken up yet. He might have done, in which case it might be on the website. It's not dramatically different to version 0.2.0, if that is the one that you have, but there are a few smallish corrections that have gone in. Okay. I'm not going to cover the notation. It's quite dense and it will take a long time, and I think we can probably cover it as we go along. We will therefore begin at chapter or section 4, the overview. So our formalisms begin with this very, very basic equation. It's not particularly dissimilar from the beginning of the formalisms of the yellow paper. And we're basically just here saying, firstly, we're naming sigma as our state, right? That's the state of the blockchain. We are naming capital bold B as our block in question. We're considering one block at a time. We have this capital, I believe, upsilon. That's our state transition function. And we have, we use this prime denotation. Where's my... I can't get rid of... No. Can I do this? No. Okay. We have this prime thing, this apostrophe that we put after it. That means posterior. So our posterior state is the state transition function applied to our prior state and the block. Now, if you go to blockchain like Ethereum, where everything is very transaction oriented, this state transition function works in terms of transactions, right? We take a transaction, we apply it to the state, we end up with a new state. Here, we're doing it in terms of blocks because, as I mentioned before, we don't have transactions and we are not considering things in terms of these discrete elements. We're considering things one block at a time. That's just the nature of this protocol. I mentioned before there are these different